Okay, for the last problem in this section, we're going to find all of the zeros of this fifth degree polynomial. Okay, so this is going to take a little bit of work. Now, before we do it, let's just think about what we would be doing when we might be asked to find all the zeros of a polynomial. If we're going to graph it, for sure we're going to need to find all of the zeros because all of those points represent the x-intercepts. And how many do we expect to find? 5. Now it's possible that some of them will be repeated. You know, if the multiplicity is 2, it might be possible to find a zero that repeats more than once. So there may not be 5 different roots, but we'll find out here. Let's start off by finding the possible rational zeros, which is going to be we have to look at all the factors of 8 over all the factors of 2. So we'll have, and we have to do pluses and minuses. So on top we'll have a 1, 2, 4, and 8 over a 1 and a 2. Okay, so the way we'll write this out is I'm going to put all of these over 1 and then all of these over 2. So first we'll just have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And now we're going to put all those numbers over 2. So plus or minus 1/2. That's unfortunate. Fractions are tougher to plug into this, but we'll see. Then 2 over 2 is a 1. We have that. 4 over 2 is a 2. We have that. And 8 over 2 is 4. We have that. This is the entire list of possible rational zeros. Okay, so let's use the factor theorem. If you prefer using synthetic division, you could do that. But I prefer using the factor theorem to try to find a zero. So what we're going to do is go through this list until we find a zero. And I'll tell you right now that f of 1 is not equal to 0. F of negative 1 is not equal to 0. Okay? Oops, not equal to 0. So 1 and negative 1 do not work. Let's see. F of 2 is not equal to 0. And I'm going from memory here, but I do believe that negative 2 is going to be the first one that we find. So let me just check that. F of negative 2. All right, that's going to be 32 times 2 is 64, and it's going to be negative. Negative 64 for the first term. 2 to the 5th is 32. Negative 2 to the 5th is negative 32 times 2 is negative 64. This will be x to the 4th is going to be 2, 4, 8, 16 positive. 16 times 7 is 112. And then we've got x squared, which is 4, times negative 18 is negative 72. And then we've got, if x is negative 2, that would be plus 16 and plus 8. So the positive numbers, 112 and 8 is 120, 136. And the negatives add up to negative 136. Got it. So negative 2 is a 0. It's our first 0. So now we need to divide. That means that f of negative 2 is 0, so x minus 2 is a factor. I said that wrong. It's x plus 2. It's x minus a negative 2. X plus 2 is going to be a factor. All right, so I'm going to put the 0, I'm going to put negative 2 in the cup. And I'm going to go 2, 7, let's see. Ooh, notice there's an x cubed missing. So we're going to say 2, 7, 0, because x cubed is missing, negative 18, negative 8, and 8. So we're going to now find out just exactly how many times x plus 2 goes into this f of x. And I know the remainder is going to be 0 because x plus 2 is a factor, because f of negative 2 is a 0. Okay, so let's do this. We bring the 2 down. Negative 2 times 2 is negative 4. Add it, we get a 3. Negative 2 times 3 is negative 6. Add it, we get negative 6. Negative 2 times negative 6 is a positive 12. We get a negative 6 when we add the column. Negative 2 times negative 6 is a positive 12. When we add that, we get 12 minus 8 is 4. Negative 2 times 4 is negative 8. And sure enough, the remainder is a 0. So at this point, we know that f of x is equal to this x plus 2 that we factored out times the result of this division. This is the coefficients. So we started with an x to the 5th. So this is going to be x to the 4th, this term. 2x to the 4th plus 3x to the 3rd minus 6x squared minus 6x plus 4. That's just factoring out one term. We've got to continue. We've got a lot more to do. We've got to factor this now, this new polynomial. If you wanted to call that g of x, you could. So this is f of x. We found out f of x is x plus 2 times this g of x. All right, so we can create a new list of rational zeros with factors of 4 on top and the factors of 2 on the bottom. And that means, one important point is these are the only possible rational zeros. So we don't ever have to try anything outside of this list. We already tried plus and minus 1 and it failed. And now the possible rational zeros of this would be factors of 4 over factors of 2, which means 8 is not a possibility. That's gone. And the rest remains the same. So now our possibilities are this guy, and this guy. All right? Well, let's try, let's see, positive 2 failed. So positive 2 is not going to work. Let's try negative 2 again. I'm going to call this g of x, this polynomial right here. So I'm going to look and see what g of negative 2 is. G of negative 2 would be 2 times negative 2 to the 4th. 32. Negative 2 cubed is negative 8 times 3 is negative 24. Negative 2 squared is 4 times negative 6 is negative 24. Negative 2 would be a plus 12 and then a plus 4. Plus 12 and plus 4. All right, so what do we get here? The positive numbers add up to 32, 42, 43, 44, 48. And the negative numbers add up to negative 48. So g of negative 2 is equal to 0. So x plus 2 is another factor. It's a factor of g, this part of f. Okay, so now I'm going to do synthetic division again. I'm going to put negative 2 in the cup, and I'm going to put 2, 3, negative 6, negative 6, 4. Let's see how many times x plus 2 goes into this. And I know the remainder is going to be a 0. Okay, so we've got, bring the 2 down. Negative 2 times 2 is negative 4. Add that column, you get a negative 1. Negative 2 times negative 1 is a 2. Add that column, you get a negative 4. Negative 2 times negative 4 is a positive 8. That gives you a 2. Negative 2 times 2 is a negative 4. When you add that column, the remainder gives you a 0. So that means that I could write g of x as being x plus 2 times this polynomial. But instead of writing g, I think I'm going to write f. F of x is this x plus 2 times g of x. But g of x is this x plus 2 right here times this polynomial, which would be, let's see, g of x was a 4th degree polynomial, so this is going to be a 3rd degree, 2x cubed minus x squared minus 4x plus 2. All right, so now we've broken down f from this. We factored out 1x plus 2, and we got this. And now we factored an x plus 2 out of this, and now we have x plus 2, which eventually I'll call that x plus 2 squared, times this polynomial. And maybe I'll call this one h of x. Let's factor it now. Okay, let's see. I'm trying to go, I've worked this out years ago. Negative 2 fails. I think, unfortunately, it's going to be something like positive 1/2 or negative 1/2. So I'm going to try, I'll try positive 1/2 first. Let's see if that makes sense. That'd be, I think it's going to be, I'm going to try negative 1/2. So I'll call that h of negative 1/2. See, I'm trying to save time here. I know that plus and minus 1 won't work. I know plus and minus 8 don't work. We checked plus 2, it doesn't work. Negative 2 worked twice, and I remember that it does not work again. And I don't think 4 worked. You can test all of these if you'd like. I'm going to start with negative 1/2, and then I'll go to positive 1/2, just to see if we can find the next zero, the next factor. So that's going to be, let's see, x cubed is negative 1/8. 2 over negative 1/8 is negative 1/4. These fractions can get painful. Minus 1/4. Minus is going to become a plus 2 and a plus 2. Nope, that's not it. So let me try h of 1/2. H of 1/2 is going to be a positive 1/4 minus 1/4. Positive 1/2 is minus 2 plus 2. That's 0 and 0. There we go. So h of 1/2 is equal to 0. So x minus 1/2 is a factor of h. All right, so that means 1/2 goes in the cup. 1/2. And I'm going to put these coefficients right here, 2, negative 1, negative 4, 2. 2, negative 1, negative 4, 2. And assuming I don't make any arithmetic mistakes, we're going to end up having a 0 down here. Okay, 2, and then 1/2 of 2 is 1. And that column adds to 0. So 1/2 of 0 is a 0, so we get negative 4 when we add the column. 1/2 of negative 4 is negative 2, and as expected, we got a 0 remainder. All right, we're very close now. That tells us that h, this h, is equal to x minus 1/2, that factor, times whatever we get down here. 2x squared plus 0x minus 4. So I'm going to write that as f of x equals, I'm going to take these two factors, x plus 2, and I'm going to square it instead of writing it twice. And now h of x is, we factor out the x minus 1/2, and then we're left with this. which is 2x squared minus 4. Well, this is pretty easy to factor. We don't need it. We don't need to do anything like we did above. Maybe I'll use the square root property. I'm going to come right down here, and I'm going to find out how to factor 2x squared. We want to have x's, just x plus or minus a number. So 2x squared minus 4 equals 0 means that 2x squared equals 4. I added 4 to both sides. Let's divide both sides by 2. Dividing both sides by 2 gives us x squared equals 2. Okay, so that means that x, let's see, x is equal to, what would we, if we use the square root property, it's going to be a plus or minus radical 2. Plus or minus radical 2. Correct? So that means if the x plus or minus 2, there's zeros of this term right here. So the factors would be x plus radical 2 and x minus radical 2. All right, let's see. Actually, I think we're missing one thing when I do it this way. I divided everything by 2. Let me, let's scrap this. Sorry about that. I want to factor this correctly. Let's just start off by pulling out our zeros were absolutely correct, and that's all we need, but I want to make sure that f gets factored correctly. Let's pull the 2 out of this, okay? Notice both of those terms. So I'm going to put the 2 way up front. And what happens when I pull a 2 out of here? I get x squared minus 2. Yeah, this makes our lives much easier. Factoring this is quite easy. You could plug it into the quadratic formula. You could use the square root property. You can actually pretend like x squared minus 2 is a difference of 2 perfect squares. This turns out to be x plus radical 2, x minus radical 2. No matter how you do it, that's what you're going to get. So I'm going to write it out. 2 times x plus 2 squared. X minus, that's supposed to be a half, not x minus 12. X minus 1/2. And this is going to be x plus radical 2, x minus radical 2. And that is the fully factored form of f of x. Whew. Okay, now what were the instructions? Find all the zeros. So, now that we've completely factored it, the answer will be easy, but we haven't written the answer yet. We have to set every factor, not the 2 never equals 0, but we'll set that equal to 0, that equal to 0, that equal to 0, and that one equal to 0. So we're going to get the zeros of -2, and that one actually has multiplicity 2, and then we'd have 1/2 as a 0, and then we have, I'm just going to write plus or minus radical 2. That's 2 different ones. So as expected, we got 5 zeros, only x minus 2 showed up twice. 2 of them were -2. And then we got a 1/2, and then we got a plus radical 2 and a negative radical 2. So that was a very long problem. So let's just scan that one more time. We started off with the possible rational zeros, and we factored out an x plus 2, and then we factored out another x plus 2, and then we factored out an x minus 1/2, and then it left us with this. We factored out a 2 right here, leaving us x squared minus 2, and then we just factored this, x squared minus 2 equals 0 means x squared is equal to 2. So the square root property would be x equals plus or minus radical 2. And that gave us the factored form of f, and then this would be the zeros.